Now we're going to solve for centripetal acceleration for major massive objects like a planet or a moon. This particular physics problem says the moon has nearly a circular orbit around the Earth with a radius of 384,000 kilometers and a period, which is time, of 27.3 days. What is the moon's centripetal acceleration? It's good to draw a diagram first for your overview. We've got a radius of 384,000 kilometers and time is 27.3 days. Now, right off the bat, we should identify these units are not velocity units. Velocity is meters per second. So we need to convert the kilometers into meters and the days into seconds. Now, with large numbers like 384,000, we're probably going to get our answer in the millions or billions. And that requires the knowledge of scientific notation. And that's how you shrink large numbers into smaller numbers using exponents. And this is how you do that, converting into scientific notation. You take your number and you move the decimal all the way to the left until you reach the ones place, like this. We have 384,000. The decimal's right here. I'm going to move it 1, 2, 3, 4, 5 times to the left. So my number becomes 3.84. So this becomes the ones place for the number. And all of these.
Good afternoon, everyone. This is a reminder for all those students that are participating in the bowling, stop, drop, them, that we will be meeting in the library today. Once again, for the students that are participating in the bowling, stop, drop, them, we will be meeting in the library today. Thank you.
So with the decimal moving 5 places to the left, we can make this 3.84 equal times 10 to the 5th power, just like I have here. 3.84 times 10 to the 5th is the same thing as 384,000 kilometers. So we're going to use this from now on. We need to convert this 3.84 times 10 to the 5th kilometers into meters. So our third step is to have our radius multiplied by conversion factors to make meters. In every kilometer, there is 1,000 meters. And when we simplify this, it's going to equal this fraction, right? I just carried everything over on the top, carried everything over on the bottom. That didn't cancel out. And when I enter this in my calculator, I want you to use these steps. So look at my screen. We first need to make sure our scientific calculator is the same as the one you have at home. The one you have at home, you should have this button saying X minus 1. And when you enter this in, we would go 3.84 second X minus 1. Oh, this needs to be converted into scientific notation, which is right here. Okay. Okay, so let's back it up for a second. We want to multiply this times 1,000 and any other numbers that are in scientific notation on our calculators. So the calculators I have at home or in this class is requiring it to be in scientific notation mode. So the way to do that is you click second and then this button DRG, and then it'll give you options to choose scientific notation or other options. Like I'm looking at the calculator right now in the class, and it says flow, psi, or ing. I want you to choose psi. So your calculator says psi and degrees. Now you can do scientific notation. All right, so let's go ahead and put in 3.84. You'll hit second, and your button here is x minus 1. In this particular instance, I only have EE. So when I click that, I can put in my exponent. What did we say it was? 5. I'm going to multiply that by 1,000. And I get 3.84 times 10 to the 8th. And that's the same thing as 3.84 E8. My E represents the times 10 raised to the 8th exponent. And that's meters. So that's my R. We're going to do the exact same thing with time. So T equals 27.3 days multiplied by a conversion factor. And each day there are 86,400 seconds. So when I multiply these across, I put in 27.3 times 86,400 in the calculator, and I'll get 2.36 e to the 6th, or 2.36 times 10 to the 6th. Let's show you how that works. We'll clear this off. So we'll flag this 27.3 times 86,400. Let's make sure this works. 27.3 times 86,400. So this website is not the most reliable. Try that one more time. Scientific mode. 27.3 times 86,400. It gives us 2.36 times 10 to the 6th, or E6. Now we use these values to plug in for our acceleration. Our acceleration is velocity squared over radius. And this is centripetal acceleration. So we plug in from our previous problem, the formula for velocity of a object traveling in a circular motion is 2 pi r over t. Plug in, simplify, divide. And this is our velocity that we plug into our acceleration equation. Plug in, simplify, C, and then that's our final answer. 2.7 e to the negative 3 meters per second squared.